my name is Mike and welcome to my build video for the Zlob Modular SVF Eurorack module. Here's the package it comes in. There are no instructions included. The instructions are available on Zlob Modular's website. So during this video I'll be following along with the instructions on my phone. Let's go ahead and open this up. I should mention that this is not a sponsored video. I bought this kit with my own money, so I'm free to share my honest reactions to this module and the kit. Here is the panel. You can choose if you want to go with this more basic design, or I prefer the more ornate design. This is the control board. As you can see, Zlob Modular makes modules that are very thin in terms of HP, and the trade-off is that you end up with deep modules. Some SCIFs are relatively shallow, so if you have a shallow case, that could be a problem for you. I do want to mention that the music in the background that you're hearing right now is made using the Zlob Modular SVF module. The kit comes with the different components already marked. These are 0.1 UF capacitors. Here we have 100K resistors. I'll just set these other resistors off to the side because the instructions have us starting off with the 14 100K brown, black, orange, brown resistors. And that's what this is. I'm going to trust this. I'm not going to get out the multimeter because as long as the colors match and it's marked, I'm going to take them at their word. Now, one thing I want to point out is that these resistors are larger than the Befaco resistors that I usually use, so it is easier to read these color bands. I'm not colorblind, but sometimes looking at these color bands it gets confusing. Red and orange start to look alike, brown and purple start to look alike, etc. If we look on the PCB here, let's see how close I can get while still being in the light. A lot of other PCBs will say resistor 1, resistor 2, resistor 3, and so on. This board has the actual values printed on it. So I can see 100K, I can see 20K, I can see 33K, 1K, etc. I'm just making sure we have 14 100K resistors, and we do. So let's get started. One thing I want to say, when you're using your phone for instructions or a computer, tablet, whatever, and you're touching all this lead solder, you're going to want to make sure you clean your phone or other device thoroughly afterwards. You don't want any lead particulates staying on your phone and later on you're scrolling through and eating a sandwich or whatever, so be extra mindful of that. Next up, we have 5 1K resistors. Let's see what these are. Brown, black, brown, and yes, they are. They're marked here. That matches their color scheme, so I'm going to go ahead and trust Zlob Modular. There's 3 more resistors left, but the instructions don't want me to place them yet. After I solder the rest of the resistors, the instructions will have me move on to the ceramic capacitors, so I'll set those last 3 resistors aside. Here are those last 3 resistors, but we're setting those aside for now. Instead, we're going to move on to the capacitors. We've got to be careful here. We've got a 0.1 UF capacitor right next to a 0.001 UF capacitor. Of course, the instructions have an image to help out and show us exactly where the 0.1 UF1 should go. Now we have the large red film capacitors. Here are the final 3 ceramic capacitors, each with their own value. Next up are the electrolytic capacitors. These are polarized, so the long leg must go into the positive hole. Now we're fishing out 2 5-pin headers. Together, these 2 5-pin headers are going to be the power pins. Personally, if I had a spare power pin header handy, I'd use that instead, but I decided to make do with what's included in the kit. I'm testing out the orientation of the 2 PCBs to make sure I'm setting the power pins right. The very first time I built a Zlob Modular Diode Chaos kit, I put the power pins on the wrong side of the PCB, which meant that the module was going to be too wide. I've soldered 1 pin on each 5-pin header so I can test out the power cable orientation. This was a mistake, as I needed to solder 2 pins on each header to keep them secure. I'm lucky I didn't accidentally bend a pin or otherwise damage the pin header when I unplugged this power cable. Now that the pins are secured, I'm testing out the power cable again just to make sure everything will work right. Next up are the pin headers for the jumpers. There are 2 3-pin headers and 1 2-pin header. The 2-pin header is a bit awkward to deal with. I end up needing to use one of the cardboard tabs to press it down while I solder it in place. The next thing, per the instructions, is to add the right-angled pin header. I hesitate to do this because it seems like it would make laying the PCB flat harder for soldering the remaining components on it. You'll see me consider skipping to the next step, but then I decide to go ahead and do the right-angled pin header. You'll see me carefully checking how this will look when connected to the other PCB. I don't want to make a mistake because this 15-pin header would be very difficult to desolder. It's better to take the time and be cautious than to make a mistake that can actually take twice as long to fix as building the entire module. Now we're adding two 3-legged transistors. The instructions tell us to bend the two transistors toward each other and then put an elevated resistor between them so that they're both touching the resistor. Now I'm not sure if this shields them from interfering with one another or what the purpose of this is. Here I'm showing the arrangement. Now we're adding the IC sockets. I'm not entirely sure why the instructions have us adding the IC sockets now after the taller components like the capacitors, pin headers, and transistors were added. It seems like it would have been easier to add the IC sockets and the diodes after the resistors. Next up are the diodes. It is important that the stripe on the diodes matches the stripe printed on the PCB. Now we're adding the final resistors to the control PCB. Next up, we're adding a trimmer. One of the legs of the trimmer is right under where the resonance potentiometer is going to be. So the instructions tell us to trim that leg down. After I trim it down, I reflow it just to make sure we still have a good connection. Now we're placing the potentiometers and jacks, but we're not soldering them yet. Before we do that, we're going to attach the front panel, then hand tighten the nuts, and then we'll solder the pots and jacks in place. Initially, I considered not soldering the location lugs on the potentiometers, but then I decided there wasn't really anything I couldn't reach with the pots there if I had to. I was having a hard time keeping the PCB flat, so I used one of the knobs to try to counterbalance the height of the pots. Now I'm combining the boards. The 15-pin right-angle socket still needs to be soldered to the control PCB, which is very tricky with the front panel already in place. Next, we're plugging the ICs into their sockets. It is important to make sure that they are facing the correct direction. Now I'm placing the jumpers. Initially, I'm setting it up for pinging, Self-Oscillation On, and max resonance off. Now I'm tightening the nuts on the front panel using a pliers. I take extra care not to let the pliers touch the panel, as I don't want them to mar the wonderful design on the faceplate. Next, we're putting the knobs on the potentiometers. And the last thing we do before testing the module is check the continuity of the power pins to make sure they're not shorted. Now we're testing the module with self-oscillation on and max resonance off. Just for fun, here's the SVF with max resonance on. And now for some tunes. Thank you so much for watching my video on building the Zlob Modular SVF. If you watched all the way to the end, please consider liking and subscribing. Have a great day.